Hi children, how are you? Now again we are here to see some more articles regarding work and energy. In this chapter we have seen what we have seen expression for kinetic energy, that is 1 by 2 mv square. Expression for potential energy, that is mgh. Then different forms of energy we have seen. Now today we are going to see one more new article, that is law of conservation of energy. Is it clear? So now ready for that. What is that? Law of conservation of energy. Law of conservation of energy we are going to see. Dear children, we have seen earlier different kind of energy, and we have seen that energy can neither be created or nor be destroyed. Energy can only be converted from one form to the another, from one form to the another, It can neither be created nor be destroyed. It can neither be created nor be destroyed, and as such I can say, my dear children, the total energy of the universe remains constant. The total energy of the universe remains constant. It is clear? Write down. So this is we are going to see. In earlier we have seen the transformation of energy from one form to the another form, or I can say in all such cases energy in one form disappears and reappears in the another form. Whenever measurement is possible, we have been able to prove that the loss of energy of one system is exactly equal to the gain in energy of the another system. जितना हमने लॉस किया है उतना हमने गेन कर लिया है. Is it clear? So I can say, my dear children, thus I conclude that energy is conserved. Or that is called law of conservation of energy. Is it clear? So this is that. So this conclusion is called the law of conservation of energy, or we can write in this form. So write down. Now we are going to prove law of conservation of mechanical energy in case of a freely falling body. When the body is freely falling, like in this manner, see here. When the body is falling freely, I am going to calculate the energy of this system at this position, total energy. Then I will calculate here the energy of this system, total energy. Then at the ground, the total energy. If at all the positions, if I get the total energy is same, so I can say this is the law of conservation of mechanical energy. Is that clear? So let us begin. We are here to see what is that. So we are going to prove, it's a very, very important article, my dear children. So write down here. Law of conservation of mechanical energy. Law of conservation of mechanical energy. In case of a freely falling body. In case of a freely falling body. Is it clear? For that, suppose let us consider a body of mass is placed at a point A. Say this is the point A where the mass of the body M is placed. Here it is the ground B. This is the position of ground. The height AB here from A to the B is H. This is the height here. We can write this is height H of the body above the ground, and in between I am taking any another position, say S. In between we are taking a point, say a point C. Here is the point B. So height from the ground here is total height is H, so this is H minus S. S is the distance of any point C from the point A. G is the acceleration due to gravity. What is G? Bolo. Acceleration due to gravity, sir. We know the value of it is 9.8 meter per second square. So I can write here, my dear children. Suppose at the point C, the velocity of the body is V1. At the point A, the velocity of the body is 0. And at the point B, say the velocity is V. So V is the velocity of the body at the point B, a point just above the ground. A point just above the ground. At that, the velocity is V here. So the velocity at the point A is 0. U is equal to 0. I am going to find out at A first. See in my figure what is at A. That is now at a point A, the potential energy at a point A. Who will tell me potential energy formula? Sir, I can mgh. The potential energy at a point A is equal to, I can write here, E at this point A, that is EPA, that is mgh. And at a point A, the kinetic energy is, because the velocity is 0, I can write 0. So the total energy at a point A would be the sum of potential energy plus kinetic energy, that is sir mgh, plus 0, that is mgh. This is our equation number 1. You can write. So this is the total mechanical energy at the point A. Is it clear? Yes sir. So write down. Now I am going to see at the point C. So at the point C, write down at the point C. At the point C here. When the body moves from A to the point C, it covers a distance S. If V1 is the velocity at C, then according to the third equation of motion, what is that? Give the answer. Sir, V square minus U square is equal to 2AS. Write down here. V square minus U square is equal to 2AS. Use this equation here. So I can write V1 square is equal to 0 is equal to 2A. Acceleration due to gravity, that is G into S. So V1 square is equal to 2GS. So kinetic energy at a point C, velocity is V1. So I can write 1 by 2 m V1 square. That is 1 by 2 m into V1 square 2GS. Here, this is V1 square is equal to 2GS. So that is 2 se 2 cancel. So here it mgs. This is the kinetic energy at a point C. Now I can calculate the potential energy. The potential energy at a point C Who will give the answer? Potential energy at a point C. Sir, the formula for potential energy I know. Tell me, that is mgh. Here the height you can say mg, and here from here to here the height is s, and from ground it is h minus s. So I can write the potential energy would be mg into from ground it is h minus s. This is the potential energy. So the total energy at the point C, kinetic energy at the point C plus potential energy at the point C, yes sir, mgs plus mg into h minus s. So I can write mgs plus mgh minus mgs. So this and this cancel. The total energy again we can see, that is mgh. So you can see this energy is equal to the energy of A. Is it clear? Yes sir. Now third point, at the point B, just above the ground. So what I can do here, at a point B I can write according to our equation, वही third equation, v square minus u square is equal to 2as. See here, initial velocity is 0, final velocity is v, acceleration is g, height is h. What is there? U is equal to 0 sir, v velocity, a is equal to g sir, s is equal to h. So I can write v square, this is 0, twice of gh. This is the value of v square. So kinetic energy at a point B, again tell me what is the formula for kinetic energy? Sir, 1 by 2 mv square. So I can write 1 by 2 mv square, 2gh, 2 से 2 mgh. Now then the potential energy at the point B, बोलो कौन देगा जवाब? सर potential energy तो जीरो हो गया, क्यों? The body is near the ground, yes. So potential energy is 0, kinetic energy आ गया आपके पास. The total energy at the point B is equal to kinetic energy at the point B plus potential energy sir at the point B. That is mgh plus 0, that is equal to mgh. This is our equation number 3. So you can see here from our equation number 1, 2 and 3, all are equal. All are equal. I can write here from our equation 1, 2, 3, I can say E of A is equal to E of B is equal to E of C. It's a very, very important result that will definitely come in our examination. What I can write here, the total energy remains constant. So clearly I can say the total mechanical energy at a point A, at a point B, at a point C, all are same. Okay, I can say, write down the conclusion, the total mechanical energy of the body throughout the free fall, जब बॉडी ऊपर से गिर रही है, throughout the free fall is conserved. Write down. So what is going on here? When the body is going down, as the body falls down, the potential energy goes on decreasing, whereas kinetic energy goes on increasing. So potential energy is decreasing, kinetic energy goes on increasing. Here we have neglected the effect of air resistance. Important बात है ये, नोट कर लेना. समझ आ गया? Yes sir. So effect of air resistance on the motion of the body are neglected. Is that clear? Yes sir. Write down. Okay. It's okay. Bye.